Okay, let's do a couple of calorimetry problems. Let's try a 400 gram steel blade, so we're working on steel, at, let's say we're tempering it, so let's say the temperature is 260 degrees C, is immersed or is quenched in 2000 grams of water. At 20 degrees C. What is the final temperature? So, final temperature. So basically, we're making a steel blade or plowshare or something. We have some water. We drop a red hot blade in there. Well, it's not actually red hot, but there's this. And we're going to assume that this is an adiabatic reaction. What that means is no heat is lost to the outside atmosphere. So we're going to assume that all of the heat from the blade goes in to the water. So what do we know? We know mass of the steel is equal to 400 grams. We know the mass of the water is equal to 2,000 grams. We know temperature initial of the steel is equal to 260 degrees C, and we know the temperature initial of the water is 20 degrees C. We also can then go and look it up, and if we look it up, C for steel, the specific heat of steel, is 0.511 joules per gram per Kelvin, which is the same as 511 kilojoules per kilogram. We can also look it up for water. That's equal to 4.186 joules per gram per Kelvin. Now what actually happens here is there is going to be a change in heat. So change in heat of the steel is going to equal the mass of the steel times this times the what's that going to be? That's the specific heat of the steel times the change in temperature of the steel. So that's going to be temperature final minus temperature initial. That's going to equal, so it's going to equal that. But the change in heat in the water is going to equal the opposite of the change in heat in the steel. So any heat in the steel must go into the water. That's what we've said. We've set it up as an adiabatic reaction. So we can write this equation. So that means the change in heat in the water is going to equal minus the mass of the water, because that, let's just change that around, times the specific heat of the water times temperature final minus temperature initial of the water. It's going to be, okay, and the temperature here is going to be the same. That's actually what we want to find out. So the temperature final for the steel is going to be the same as the temperature final for the water. So we can write this out. Because this is equal to this, is equal to the negative of that, we can actually write it out. Mass steel, C steel, temperature final minus temperature initial steel is equal to the mass of the water, negative the mass of the water, C water, temperature final minus the temperature of the water final. Now we can do this the engineering way, possibly the easiest way for people who aren't going to become physicists for the rest of their life, is just plug in numbers. So what do we know about, and we're going to plug in numbers about units for a change. So we know the mass of the steel is equal to 400 times CS, which is the specific, which is equal to 0.511 times temperature final, TF, minus, do I know the temperature initial of the steel? Yes, I do, 260. Equals minus 2,000 grams times 4.186, because that's the specific heat of the water, times TF, which we don't know, minus the initial temperature of water, 20. Okay, so just a bit of calculator time here. 400 times 0.511 equals, so it's going to be 204.4 times TF minus 260 equals, again, 2000, so it's going to be minus 83672 times TF minus 20. Now what we have to do is expand these brackets out. So it's going to become 204.4 TF minus, 204.4 times 260 equals negative 8372 TF plus, because remember minus times minus, it's going to equal plus 8372 is 167,440. Yep, because it's just that times that. So 204.4 TF minus 204.4. What's that? 53,144. 53,144 equals 9,372 TF plus 167,440. Now what we can do, everything that's TF we put on one side, everything that's not TF we put on the other side. So I'm going to add this to that side. So 204.4 plus 83,072 TF on that side equals 167,440 minus 53,144 plus we add that to both sides, my apologies. So we end up with, what's that, 204.4 plus 8372 equals 8576.4 TF equals 167,440 plus 53,144, 220,584. And now we just divide both sides by 8576.4. That cancels out. 8576.4 divided by 8576.4 equals, so TF equals 25.72 degrees. And if we want to, we can check that. We can just stick that value into those equations and yeah, works fine. So yeah, this is the tricky part here, is that the heat here, change in heat here, equals the minus of the heat here. So any heat lost here in the steel must go, and it doesn't matter if you say this one is minus or that one is minus. As long as one of them is minus, the math will come out fine. But you have to be very careful of your plus and minus signs all the way through this. Otherwise you're going to end up with the wrong answer. So that's the basic way. Make a big equation where mass of steel, CS, change in temperature equals mass of the water, specific heat of water, change in temperature. That side's all negative. Plug in the numbers, simplify down, rearrange, and you will end up with the answer. Cool.